Hello, my name is Darren Holmes, and today we're going to be using the EMAC Primer Trainer and looking at lesson number 7, 16-bit addition. So we're going to be using two new instructions, the ADD E, opcode 83, and the ADC D, opcode 8A. So the ADC adds the D register and the carry to the A register, storing the result in the A register. And of course the flag bits will be affected. So page 740 of the 5th edition of your textbook has the add command, add register to accumulator, and we can see it's 1 byte, 1 machine cycle, and 4 T states, unless we're trying to add something from memory. So we're looking for the add E, and you can see its hex code is 83. And the contents of the operand, register or memory, are added to the contents of the accumulator, and the results stored in the accumulator. And as you can see on page 739, we have the ADC instruction, add register to accumulator with carry. You can see it's 1 byte, 1 machine cycle, and 4 T states. We're looking for the ADC D instruction, so that's got a hex code of 8A. It says the contents of the operand, register or memory, and the carry flag are added to the contents of the accumulator, and the result is placed in the accumulator. The contents of the operand are not altered, however, the previous carry flag is reset. And just below the command, we have an example, and we're going to add some register pairs. So they're going to assume the BC register pair contains one number, the DE register pair contains another number, and we're going to add these 16-bit numbers and save the result in the BC register. So they show you all the steps to do that, just like we're going to be doing in lesson 7. So as in other lessons, they say here the same concept used in the previous lesson, which was the 16-bit subtraction, can be applied to make a 16-bit addition program. Now you can see we're going to start the program off at FF01. We're going to add the low order bytes first, and that's going to generate a carry bit. So in the next step we're going to add the high order bytes and the carry flag. So once again, they've given us all the opcodes that we need to type into the primer trainer. So we're to load the BC register pair with 2302 hex, and then load the DE register pair with 10FF hex. And it says the following is an equation that the program will perform. So it helps if you go through these calculations yourself. We're going to load 2302 into BC, and we're going to load 10FF into DE. So doing the math, remember this is hexadecimal math, so F plus 2. So F plus 1 is 16, so there's that bit there indicating a carry, and we'll have 1 left over. So then F plus the 0 plus the previous carry, right, is going to generate another 16, right? F is 15 plus 1 is 16, so that carry bit goes over to the next column, and we end up with a 0. And then we end up with 3 plus 0 plus the carry bit is 4, and then 2 plus 1 is 3. So our answer ends up being 3401 in the hexadecimal numbering system. So in order to figure out what the flag register is going to contain, we have to do the calculation based on binary numbers. So we're going to start with the low order addition. So we're going to start with 02 plus FF. So you have to remember 0 is 0000 and 2 is 0010. And then F is just 1111, 1111. So when we add these together, we end up with 1 plus 0 is 1. And then in the next column, 1 plus 1 is 0, carry the 1. And then 1 plus 1 is 0, carry the 1. And then 1 plus 1 is 0, carry the 1. Okay, so that's our auxiliary carry bit being set. Then 1 plus 1 is 0, carry the 1. 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 So that's our carry flag being set. And then for the parity bit, we just add up the number of ones, and if they're even, we add 1. If they're odd, we don't add anything. So in this case, the parity bit ends up being 0. So our answer is 0, 1 in hexadecimal. The carry flag will be set, the auxiliary carry bit will be set, and the parity bit will be reset. So that's the first step, the low order addition. The next step is the high order addition with carry. So that's the 2, 3 plus the 1, 0. So remember that 2 is 0, 0, 1, 0, and 3 is 0, 0, 1, 1. And then the 1, 0 is 0, 0, 0, 1, followed by 0, 0, 0, 0. So 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 is 0, and notice there's no auxiliary carry bit. And then 0 plus 1 is 1, and then 1 plus 0 is 1, and then 0 plus 0 is 0, 0 plus 0 is 0. So there's no carry bit. Now if we're looking for a parity bit at this point, we have 1, 2, 3, 4 ones in our accumulator, so the parity bit would be 1. But this command also adds in the carry bit, so we have to do that before we check the parity bit. So in our case, the parity bit was set, so it ends up being 0, 0, 0, 0, 0, 0, 0, 1. So that's the carry bit set. And the result from our previous number was 0, 0, 1, 1, 0, 0, 1, 1. So we have to add the 1 bit in. So 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. And then 0 plus 0 is 0, and there's no auxiliary carry bit. And then 1 plus 0 is 1, 1 plus 0 is 1. And then 0 plus 0 is 0, and 0 plus 0 is 0. And you'll notice there's no carry bit. So we have no auxiliary carry, and we have no carry bit. To look at the parity, we just add up the number of ones. 1, 2, 3, 1 bits in here. So the parity bit is reset to 0. So our answer is going to be 3, 4 hexadecimal in the accumulator, and the flag register should be 0. So when the program is finished executing, the BC register pair should contain the answer 3401. The accumulator and the flag register, the accumulator will contain the 34, which was the part of our calculation for the high order addition with carry, and the flag register should be 00. I always like to draw out my flag register bits, and you can see that they're all going to be 0. Okay, so the first thing we need to do is turn on our primer trainer, and there will be some old code in there, probably from the last lesson. So we're going to start by entering our new code. So FF01 is supposed to be 79, and it is 79, so I'm just going to press enter. FF02 should be 83. And then 4F, and then 78, and then that should be 8A. Enter. 47, then FF. And I do recommend that you use the decrement button and step backwards just to check that you do have the correct code entered in there, or else it just won't work correctly. Okay, at FF01 we're to load the BC register pair. So I'm going to press function BC and we're to enter in 2302 and then press enter. And then we have to load the DE register pair, so function DE, and we're going to load that with 10FF and press enter. So now we're going to run the program. Instead of going function run, we're just going to step through it and see how each command functions. So at FF01, I'm going to press the step button, and A should now equal C. So function A, and we can see we have 02 in there from the BC register pair. If I step again, we should have A being equal to the accumulator, which was C, plus the E register. So in this case, we're looking for 01 in the accumulator. So function AF, and we can see that there is 01 in the accumulator. Now, checking the flag register, we can see that it contains 1, and if you decode that, the first one should decode to the auxiliary carry, which we said would be set, and the second one should be decoding to the carry bit, which we said should also be set. And of course, with nothing else set there, the parity bit is indeed 0. Okay, at FF03, we're going to step again, and now C should equal A. So go function BC, and we can see 01 has been loaded in, overwriting the 02 that was there that we'd originally put in the BC register pair. So I'm going to do another step, and now A should equal the B register. So function AF, and we can see it contains the number 23 in hexadecimal. So at FF05, I'm going to press step, and the D register and the carry flag are to be added to the A register. So in this case, we're looking for the number 34 in the accumulator. So if I press function AF, we can see that 34 is loaded into the accumulator. All the flag bits are 0, and we said the auxiliary carry bit was now going to be 0, the carry bit is going to be 0, and the parity bit are 0. So it's done all that according to our calculations. So at FF06, I'm going to press step again, and this time B should equal A. So we're going to go function BC. So we can see that the B now contains 34, and the C contains 01. So that is our answer. And if we go to function AF, we can see it's still 3400. So it copied it, it didn't move it and delete it. And if you try and step on an FF, you can see it doesn't increment. So it just stops there, returns control to the monitor operating system. Now it says in here to try pressing the reset button and loading BC and DE with other values and running the program again. It says try loading the C and E register with values that will not set the carry flag when the add E instruction is executed. So you can try that on your own, but remember to do the math first so you know what to expect. So let's review Lesson 7 using the Primer simulator. First thing I'm going to do is turn it on. And now I need to load the program into memory. So FF01, you can see it always comes up cleared on the simulator. So we're going to add 7, 9, enter, 8, 3, enter. 4, F, enter. 7, 8, enter. 8, A, enter. 4, 7, enter. F, F, enter. Hit the reset button to take us back to FF01. We now need to load the BC register pair, so function BC, and we're going to load in the number 2, 3, 0, 2, enter. And now we need the DE register pair, and we're going to load in 1, 0, F, F, enter. And now we're going to step through the program. So the first step, A equals C, so function AF, and we can see that A equals 0, 2. The next step, A equals A plus E, so checking the accumulator, function AF, we can see that we have 0, 1 in the accumulator, and the auxiliary carry bit and the carry bit are both set. The parity bit is reset. Pressing step, A should be copied to the C register, so function BC, and we can see the C register is 0, 1. The next step, B should be loaded into A, so function AF. We can see A now equals 2, 3. Notice the flag registers were not affected, so they're as before. Next step, it says the D register and carry flag are added to the A register. So function AF, we can see that the answer is 3, 4, and the flag registers are reset to 0, 0. So the auxiliary carry is 0, the carry bit is 0, and the parity bit is 0. Then at FF06, one last step. It says B equals A, so we're going to check it. Function BC. We can see we have the answer in the BC register pair of 3, 4, 0, 1. And then just rechecking the accumulator or AF registers, we can see we still have 3, 4 from our last calculation. It was copied, was not deleted, and the flag bits are reset from the last command that affected flag bits, which was the ADC command. And at FF07, if we keep pressing step, nothing happens because we're on FF, which is a restart 7, which brings us back to the monitor operating system. So for this lesson, the primer simulator is working correctly. This concludes lesson number 7 on 16-bit addition. In lesson number 8, we're going to be looking at 16-bit subtraction using 2's complement addition. We're going to be using the DAD and the CMA and the INX commands to be working on 2 registers at the same time. It's going to be exciting, so don't forget to subscribe. You'll want to know when this one comes out.